Okay, again, we're looking at mixture of questions and working with questions that you've sent in. We're going to check if there are questions that we left that too. We're going to try to look at, aim is to look at all of them, but sometimes we only aim, but we won't be able to due to time constraints. But we will try as much as possible. Please put all the lessons together from lesson 1 to 7. It's both paper 1 and 2. Paper 2 we actually did complete. We completed paper 2. So we have resources for revision on that. I know I'm skipping a few questions that I had put because I want to deal with the questions that you guys sent in before I go back to look at mine. All right, we were here. We were here on electrostatics. Let's see. Okay, organic chemistry on paper 2. All right, that's just a quick walk there. But we'll try to start pumping in through. Please don't leave paper 2 to just the weekend. It's always not enough. Just get to do it one topic, just take maybe organic like that, One second. Three metal spheres X, Y, and Z carrying charges are placed on the vertices of a right-angled triangle as shown below. State Coulomb's law. Guys, I'm just going to let that slide, right? It's the magnitude of what? The electrostatic force between two charges is directly proportional to the product of the charges and inversely proportional to the distance between their centers, not between them. For Coulomb's law, we talk about Coulomb's law we talk about between them because it's too small to measure the center. But when we talk about Newton's law of universal gravitation, we say between their centers. So let's take note of that. All right, here we use between them. Calculate the magnitude of the net electrostatic force on sphere Z. Guys, once they say on Z, our focus is now on Z, nothing more. All right, calculate the magnitude. So we're looking at Z. Now, so all you need to do is to start with a free body diagram. Quickly, everybody. So I'm going to analyze. You're going to do calculations for me as quickly as possible. We still have some time. All right, we're not going to rush now like the way we're rushing for maths. So I have Z there. Z is what? We'll be told if Z is positive or negative. They must tell us maybe there's something wrong. Three metal spheres carrying charges are placed both of the right angle. There's an omission here. No, they can't. No, we need to know Y and Z. Who sent me this question? If we can find the original. Is there, if you remember anybody who remembered who sent me this question? If you can tell me the year, can just quickly recheck the original because magnet electrostatic force on Z. We need the charges on, we need the positive on Y and Z because once they say 1,8, it's wrong. There must be, because they say three metal sphere X carrying charges are placed on the vertices of a right angle. So there must be something about Y and Z. I don't know who sent me this question. If you are here, you can try to just recheck and let me know. But notwithstanding, I'll put a plus here. They would never give you something like that. They would never. Okay, so I'm going to put plus. I'll use them as point charges for now. The principle is what we need. Okay? Now, so I'm going to look at Z. Since we are focusing on Z, let's look at Z and X. Where should Z go? Z and Y. Let's look at the vertical one. Z and Y. What's going to happen? They repel. So Z should be going where? Down. All right. So that's how we deal with questions like that. Z should be going where? Down. And the examiner is saying force. So let's call this F of Y on Z. Now, what about X and Z? Attracting, right? So Z should move towards what? X. So that's going to go that way. And what can we call this? F of what? X on Z. And I'm sure we can all calculate F, guys. F of X would be what? K QX QZ over what? R squared. F that of Y will be what? K. Now I'm using QY QZ. Do you want to do the maths for me quickly? For the first one, the distance between X and Z will be what? 6 times 10 to the power negative 2. Don't forget, it is all what? Squared. Between Y and Z, 3 times 10 to the power negative 2. Okay, guys, give me answers. I'm then going to analyze. Let's calculate F of X on Z and F of Y on Z. Quickly share those answers once you're done. Let's check answers and throw answers in. Amatle has 27 and 9. But Andle has 27 and 9,45. So let's check those answers, please. All right. Let's check answers now again. All right. 9,45 and 27 is what we are getting. Amatle, you probably need to check your calculator. Check your calculator quickly. All right, check. All right, so okay, so we agree with the 9,45. Amatle, are you okay now with the 9,45? Quickly.
Yes, sir, I am okay. I made a mistake.
All right, sweet, no problem. So which one is 9,45? Is it X?
Yes, it's
Angela, you're not here now.
Yes, sir.
And F of Y on Z is what? 27. Now, here's the deal. When we have such a diagram, our resultant would be the we have to draw a resultant parallelogram force. So let's quickly do that. This is what we did in grade 10, and I know most of us have just forgotten, no, grade 11. Most of us have forgotten. So this is a bit different from the ones we usually do. Okay, so we have that. Now check that. I have that, we have that, right? And we also have that. Now, if I draw a parallelogram of forces, what would I have? I'll have this one coming this way. That is equal to the Y. And I'll have that going that way. That is equal to the X. Remember? Fx and Fy on Z. So, we're drawing that way. We're just drawing a simple what? Parallelogram by drawing equal forces. Now, we need to now draw our tail and the head. You would notice that what do you have there? That's the tail, right? Okay. And where do we have both heads meeting? Right here. No, wait, what am I? Did I draw this thing well? And you said yes. Yeah, you said yes, child. No, yeah. This one is supposed to come. Wait, this one is down. Tail to tail. And I'm drawing. Yep, here. Okay. So you can see that this is parallelogram of fx, parallel line, and this is parallelogram of what? Fy. So you would see here is where the heads meet. And that's the tail. So what do we do? That's going to be my what? Resultant force. Alright? Tail to tail and head to head there. So how then do we calculate the magnitude? We're going to bring in a bit of math here now. Like I said, this is not a 90 degrees story. Now let's go look at our diagram to get the angles. Let's look at our diagram to get the angles. Now can you see that between Z and X it's 60 there? Alright, so, and we have 30. So let's fix our angles. Here, let me draw the whole thing because I want you to be able to see that whole diagram again. This is what we have. We have that. We have that. And we have that. So what is this? 60. And this is what? 30. X, Y, and Z. So when we drew, I'm going to draw with different colors now. When we drew this, we drew it downwards, right? And then what did we do? We drew this one that way. Make sense? So we are all conversant with the angles. Already, then we said, okay, if we were to draw a parallelogram, we are going to have that, just to be able to draw a parallelogram, and this, we have that. So can we fix our angles? If these two lines are parallel, do you see a corresponding angle here? And what would that be? 60 degrees. All right? Then we have our resultant as here. The question now is, how do we fix the angle that is here? Because at least we need one angle. Mind you, okay, we don't need. Do we know this? This is f of what? Fy. What is this? Fx. What do you notice? We have two sides and an included what? Angle. This one is an old paper, I'm sure. They really don't test that much because now it's cosine rule and sine rule and all of that. So for us to be able to get f resultant, do you see what we need? Cosine rule. So f resultant squared will be what? Fx squared plus Fy squared minus 2Fx Fy cos what? The angle that we have here, right? Because it's the opposite. Cos what? 60. What was your Fx? 9.45? Is that fine? What is this? 27. My board is lagging. 2, 9.45, 27. Cos what? 60. Please let's get F resultant. But should the examiner wants to test your maths, it's the same story. We do it exactly like that. Who's giving me an answer? Jada, did you find the square root? Did we find the square root? Matley, square root. Arifa, did we find the square root? It's squared. $23, what?
73.
Yeah. 23,73. All right. Here you are singing. So guys, that's how we do it. It's the magnitude that they want, and that's the answer. 8 marks there. So it's all about interpreting your free body diagram and applying whatever mathematical concept that needs to be applied. Whoever sent me that question, thank you. And that is it there. Okay. So we're not going to say they cannot ask. It's examinable. All right. It is, because it's sine rule, cosine rule that we all know. Awesome. So you can rewatch this again for clarity if you need to. What's next? Still on it's like, guys, we're struggling on electrostatics. So many electrostatic questions. All right, let's check this one quickly. Two identical spheres A and B carrying charges of positive 5 micro and negative 10 micro respectively. Let's help ourselves. I don't like the word micro. So what do we say? Positive 5 times 10 to the power negative 6. Do you see there's always a sign, guys? So even when you write your own answer, make sure that there is a sign there, except if the examiner says magnitude. All right. Millimeters. We don't work in millimeters, right? How do we convert millimeters to centimeters?
Times 10 to the minus 3.
So we divide by 1,000, right? So 1, 2, 3, 1, 2, what would this be? 0,03 meters, 0,15 meters. So please take note, we divide by 1,000 or times 10 to the power negative 3. Same story. The spheres A and B are allowed to touch each other and then return. Remember, when they touch each other, what happens? Then they have the same what? Magnitude. 7.2.1. Define electric field at a point. We've done this so many times. Use the formula. E equals to what? F over Q. What are we saying? The force experienced per unit positive charge. Use the formula. This is force experienced per unit. You can even say charge, but I prefer us to say positive what? Charge. That's the correct and complete definition. Draw an electric field pattern between A and B after touching. Guys, it's 3 marks. You get it in 60 seconds. Please draw, and I'm going to mark with you. Draw yours. A and B are allowed to touch and return. Now draw the electric field pattern. You have 45 seconds left. Yes. All right, we should be done. So they're going to have equal amount of charges. What you need to check, the examiner is actually tempting you here, is to check whether they are positive or negative. So let's add together. What's going to be Q new? That's very important. Positive 5 times 10 to the power negative 6 plus negative 10 times 10 to the power negative 6 divided by 2. What is 5 minus 10? Negative 5 divided by 2. Negative 2 comma 5 times 10 to the power. So you should know. This would help you with the arrow. So I could just put it here. The only difference would be the arrow. The shape remains the same. Don't draw too many things, guys. Don't draw too many things and start getting things wrong. You are fine with 3, 3. But because it's negative, it has to go inside. That's where they want to trick you and catch you.
I swapped those.
What happened?
I wrote negative on the second one and now the first one. That's right.
What do you mean?
What is negative? That is positive.
No, but they said the spheres A and B are allowed to touch each other.
So they both become negative.
Yes, you have to add and divide by 2.
Oh, okay.
So now they've changed charges. They are now of the same. So we do that calculation to check, are they going to be both negative or are they going to be both positive? Because that will inform the arrow. All right, calculate the magnitude of the net electric field at P. My dear learners, I'm just going to quickly analyze and you are going to calculate for me now. What do you do again? They said at P. What am I going to do? I'm going to start by drawing what? A free body diagram. Where? At P. We've done this over and over again, so you should be fine. A point charge is always positive. Okay. Now, if I look at B and P, what happens to P? Opposite charges. P should be attracted, right? So that is going to be electric field. Please take note. Net electric field. We are looking at E of B on P. Then look at A. What's happening? Both positive. A and P. So what's happening to P? Should move that way. What do you have? E of A. Then you choose a direction. Let right be positive. So if the right is positive, what do we have? Positive and negative. You are going to do the calculation for me now. What formula are we saying? E net is equal to what? EA is positive, right? Minus EB. Please substitute quickly. Let's see your answers. And you know E is what? KQ over R squared. Let me put a timer. I've already done the hard work. Yours is just to substitute. So 4 minutes should be fine. Because of the exponents and pressing calculators. Google, if you look at P and B, what happens? You look at them separately. P is only attracted to B, but repelling from A. Oh, wait. Oh, yeah, you are correct. After touching. Guys, we're wrong. I interpreted wrongly. It is after touching. After touching. Google, you're right. After touching, they are both negative. I was still looking at A and B being positive at the top there. Sorry, my bad. Okay, let's just create a new page. Remember, I was looking at the top there. Thank you, Google, for raising that. So A is now what? Negative. B is also what? Negative. And P is what? Positive. Thank you so much. That was a big error. What happens? It's attracted and also what? Attracted. Makes sense. Thank you. That's a very good correction there. All right, you just change the signs on the calculator now. So what's going to happen? Take left as what? Take left as positive. So what is E net? E net will be what? EA plus what? EB, which is KQA over R squared. Thank you again. That was very erroneous. Now we can substitute. What is QA? It is now what? 5 times 10 to the power what? Negative 6. But the distance of A from P, what is the distance? 0,45. Do we guys, wait, do we agree? Is it 45? 30 plus 15 will give us what? 45, right? So it's correct. But is this 0,03 correct? 1, 2, 3. 1, 2. This is 0,015. Yeah, we are all tired today. Okay, which still gives me my 0,45 anyway. So 0,45. Don't forget the squared. Plus 9 times 10 to the power 9. Again, guys, do you see that I no longer put the sign because I have dealt with the sign with the free body diagram. And this is...
Why is it still 5 times 10 to the power minus 6?
What?
Why is it still 5 to the why is it 2 5?
After touching each other.
Yeah.
What is the charge after touching each other?
This is it, 2 5.
Oh, 2,5. Gosh, guys, I'm exhausted, I see. 2,5. All right. Let's put that in the calculator. 2,5, not 5. I'm repeating the same mistake. Now let's just put in the calculator and get an answer quickly. And then we are done with this question. Share your answer once you're done. Amatle is giving me 1,11 times 10 to the power. Is it 6 or negative 6? This is Amatle's answer. Let's confirm. Is it correct? That's the same answer you have?
122.
Alright, Arifas confirmed. Amara also confirmed that this answer is correct. Okay, let me just see something here quickly. We want the magnitude, so we're fine. Magnitude, so we are fine. Please don't forget the unit. It is, bless you, force over column. That's how I remember. I use the formula F over what? Q. This one is Newton and columns. So we just write Newton per columns. Done. All right, so please let's take note of that error that we made. If there's anybody having a challenge, do let me know. We need to move. Oh, we'll move away from that and move to generators quickly. Generators. The simplified sketch of an electric motor. Quickly, let's talk about motors. What do we know? Okay, you know what, guys? Let me do something for you. Let me do something for you. Quickly, very fast. Generators and motors. This is something people always struggle with. I want to give you the notes quickly. Generators and motors. What type of conversion do we have in a generator? Mechanical to electrical energy. Why motors talks about what? Electrical to mechanical energy. Let's see if we can do something in 5 minutes on these notes. Now, the second point is where I really want to emphasize. Principle here is what? Electromagnetic induction. Now, they are going to ask you to explain it. And how do we explain it? We say an EMF is induced when a coil, an EMF is induced when a coil moves through a magnetic field, creating a change in magnetic flux. Please, this is very, very important. So when you move a coil through a magnetic field, what really changes is the magnetic flux. And when that changes, it induces an EMF. The principle here is called the motor effect. And what will that be? The interaction between the magnetic field the magnetic field of a magnet and the magnetic field of a conductor carrying current. Creates a rotation or a movement. Creates a movement. And that's what we're saying. Electrical energy converted to mechanical energy. Generators, we use the right hand rule. Motors, we use the left hand rule. Now, so those are the two major differences between them. How do you identify this one? A generator has no power source. A motor has a power source. All right, let's write this quickly, then we'll look at DC and AC, then we answer questions. All of the notes I'm going to give you will answer the questions that you may come across. Are we done writing? Are we done writing? Give me a thumbs up. Just want to look at AC and DC quickly. Just, give you a summary, and all the notes will actually help you. Yes, God rules my life. Generators right, motors left. GRML. Okay, are we done? God rules my life. Generators right, motors left. Okay, can I move now? Quickly, AC and DC, whether generator or motor, it doesn't matter. Just want to look at a few pointers here. Or before we look at AC and DC, let's talk about something. Still on generators and motors. Since we are producing electricity, we can talk about how to increase current produced. What are the points? What are the points? How do we increase current?
We use stronger magnets.
You are reading. Use a stronger what? Magnet. And that actually, okay, let's see. On motors, what are we doing? How to increase the speed. Of rotation. It's like your fan. You can just turn the knob. All right? That's what we mean. Again, we can also use what? A stronger magnet. What's next? How do we increase current? We cannot increase current to increase current. Increase the number of turns of wire. On the coil, which is the same as this one, you can also increase. Number 3, this is where they are different. Here, increase the speed of rotation. or movement of coil in and out of the magnet. While in this one, what do? We increase current.
Increase speed of rotation by increasing current.
Uh-uh.
Yeah, so that's what you said.
We increase what?
We increase speed of rotation by increasing current.
Yeah, it's fine. Increase current or decrease what? Resistance. But the most important thing here is to know the graphs. Is to know that graph.
Generators with the nodes.
Huh? So you have a graph like that.
AC.
Yeah, but I want to talk about current increase. There are two graphs I'm going to draw. I'm going to just increase current but leave the period as the same. Then I am going to increase, please, I'm going to label or explain these graphs. I have the yellow one and the green one. So which one is responsible? I'm going to use color codes. You see the yellow one is this, while the green one is number 1 and number what? 2. If we use a stronger magnet, we are just going to, let me explain. When we use a stronger magnet, what happens? Current will what? Increase. But the frequency remains the same. If we increase the number of terms, that's going to also increase, but frequency remains the same. But when I increase the speed of rotation, it means I am actually cutting time out. Instead of going 1 rotation, I'm going 2. So 2 things are happening there. Current increases while the period will do what? Decrease. So let's put a note there. They might just, examine like that. Period here decreases for the third one. Or we can say frequency does what? Increases. So once you increase the rotation, you move, there's more revolution. Please let's take note of the difference there. There is more revolution there. From here, yes, please draw it. You need to take note of that and label it as well. Label it. You can, if you don't have color code, you can label it as 1, 2, 3. The green one is 1 and 2, and the 3 is the yellow. That's very, very important. It will be tested. Generators and motors. Then we can look at what? AC and DC. Or we can just answer questions straight there. I'll use the diagrams and the questions to explain a few more concepts. 2 minutes or 1 minute to finish this page. All right, can we move on? All right, Arifa done. Guys, can we move on quickly? I need to know. Who else is still busy? Let's answer questions now. I think the information we have here will suffice for some questions. I know I want to talk about AC and DC, but I'll talk about that when we answer questions. Let's look at this one. The simplified sketch of an electric motor is shown below. Now you can see, how do I know it's a motor? Even if the examiner did not mention the word motor, I gave you the notes. How will I know it's a motor? Check. What is that? Power supply. That tells me it is a motor. Now, I want to talk. Sorry? No, it could also be in a generator. Yeah, it could be a generator. That's what I actually want to talk about. That carbon brushes and commutators. Can we talk about the uses, parts and uses quickly? Let me make sure that my conscience is clear. Just before we answer, the two ones they would ask you, part and uses, or part and function. Part and function. Number one, what's the first part? Carbon brushes. Serves as point of contact between rings and the external circuit. It transmits currents. I want you to see the difference in roles. It transmits current A from external to coil in motors, in B from coil to external in generators. From external to coil in a motor, because we are supplying the whole system with power, so it passes through the carbon brushes. But in the generator we are producing, so it's moving from the coil to the external what? Circuit. What's the next one? Commutator. Allows current to flow in how many directions? One. In every half cycle. So it is present in a DC. Whether it is a generator or a motor, it doesn't matter. Slip rings. Allows current to flow in opposite what? Directions. In every half cycle. It is present in AC. Yeah, that's very important. There's one more point I want to mention, but I'll mention while if I see a diagram. If I don't, I'll write it down. It's going to make sense when I see a diagram. All right, please let's write that. Those are basically the important notes. And then we use this to answer any question. You have 1 minute.
And must visit for your views.
Yeah. Okay, let's answer. Write down the energy conversion that takes place in this motor. It's a motor. That has been answered already. A motor would convert what? Electrical to mechanical. We're done. Is the above AC or DC? Commutator. So what's the answer? It's a DC. What is the function of commutator in this? I think I already answered. Allows current to flow in what? One what? Direction in every half cycle. Like I said, the note will answer all of the questions. So already I'm done with my 3 marks. You just read from the notes there. Copy and paste. Okay, let's look at the next one. A resistor Y is rated 200 volts, 100 watts. Please take note. Here's the thing. Whenever you see this, power average is always IRMS. Please, so take note. Power is linked to RMS, not max. So once I see that, oh, they gave me power as 100 watts, you know what they've given me? They've given me VRMS as what? 220. A lot of learners don't know whether it's VRMS or Vmax. Once I see power, it's RMS. Okay, as shown in the circuit below. Calculate the resistance of Y. Use your electric circuit formula. I have V, I have P, and I'm looking for what? R. I'm sure we know the formula. Do we know? P average equals to what? I know V. V RMS. Don't write V. V RMS over R. Use your electrical circuit formulas there. You want to do that for me quickly, everybody? 100 220 squared over R. This get me R. Oh, this I can do. 48400. Answer is 484. Am I right? Please confirm. Yeah. 3 marks, beautiful marks there. Next one. So please guys, how do I get things done so easily? Write the things you are given. Alright. Another resistor Z with a rating of 200 volts, X watt. Now we don't know that. Is connected in series. Please bring in your electric circuit knowledge. To Y, see the diagram below. How are they connected? Series. What do I know? quickly before I even answer. Series are potential what? Dividers. But current is what? The same. So we are saying IY is the same as what? IZ. Because they are connected in series. The power dissipated by Y is 80 watts, while its resistance remains constant. Or what is our R? 484 ohms. Calculate the power rating of X, assuming that resistor Z, power rating X of Z, assuming Z has a constant resistance. Look guys, the first thing I'm like I said, current is constant. Makes sense? So if I want to get power, let's see. Okay, fine. There are two ways of doing this. This thing is so easy. Let me draw the circuit here because I want us to explore. So already we are dealing with circuits again. For those of you that are having challenges with circuits and delay, this is where we deal with circuit again. So we have what? 220 what? Volts. 6 marks. We have Y and we have what? Z. What do we know about this? Power is 80 watts. The resistance is 484. What are we looking for? We are looking for the power there. Because they are connected in series, I know that 220 is supposed to be divided. Alright. So I'll look at something first. What is my formula for power? It's either P equals to IV, P equals to what? I squared R, P equals to... But do you notice I do not know the resistance? So which means I can calculate the current and the voltage. But we know, point 1, the current in Y is the same as the current in Z. Do you think we can calculate the current in Y? Yes. What formula? P equals to what? I RMS squared what? R. By the way, this is P average. I'm just playing around with these formulas. There's nothing in this question. What is the power? 80. Do I know I? Nope. Do I know my resistance? Please let's get IRMS. Everybody do the math for me. Do the math for me. Please give me I. Let's confirm. Beautiful. Thank you guys. 0.41. So already you know what I know. I already know the I here now as what? But what else? Can I get the voltage?
Yes.
I know that Vx, because they are connected in what? In series. The V in Y plus the V in Z must be equal to the total voltage. Series connection. Can we get the V in Y? I think we can. Don't you think so? Using the same formulas. Or we can even say V in Y equals to I in Y multiplied by the resistance. What is IY? 0.41. What's the resistance? 484. That's why it's 6 marks.
Answer is 198.44.
1. So what is therefore the V in Z? It is 220 minus 198, comma what? 44. What's your answer?
21.56.
40?
21.56.
Oh, we now know the P of Z. It is I RMS multiplied by what? V RMS. What is our I? 0.41. And what is that? 21.56. Multiply that and you're done. 6 marks in the bag. Give me the answer there. Let me know if it's okay. 6 marks. So we are using our series, our potential what? Dividers. That's what we are using. When they are connected in series, potential difference is divided, but current is the same. So whenever we divide to get the total, what do? We add. Please give me a thumbs up. Let me know if that makes sense. That whole 6 marks makes sense. Let me know. We're all good. We're good? All right. Let's see the next question that was sent. We're just moving through. If your question came in late, it's just this one, guys. Can I ask you to do this for me? We've done this a few number of times now. Okay, so, all right, you answer this now, 10 marks. We've done this a couple of times, like 3 times now, even today alone. So 10 marks, I'll give you 12 minutes. Please get me full marks, no stories. I won't even mark, I'll just open the memo. Make sure you finish, 10 marks. Come. Everybody.
looks exactly like me.
All right, guys, can we mark? Let me show you the memo you marked yourself, March 2016. All right, guys, here are the answers. Are you marking? Amatle, you were saying something because I wanted you to mark and see yourself.
So I wanted to know what happens if you choose a different direction
For what?
for a going to, let's say for instance you chose left, you choose right as positive.
Your answer will still be to the left.
Oh, okay.
Your answer will still be to the left. So let's see, how many of us got it correctly? How many of us got it correctly? Yay, all right. I'm seeing a lot of correct hands up there. And let me see, if you don't understand anything, let's look at it. If you don't understand, all right, if you see number one, both 1 and 2 are pointing in the same direction, so we are adding. If we are adding, it cannot be 0. Does that make sense? For it to be 0, one must be going left and the other one going where? Right. So you can see vectors E1 and E2 are in the same direction. The fields due to 2 charges add up because they come from the same direction, hence cannot be 0. All right, and the second one, so you would believe everything I've been teaching you. I wanted you to see by yourself that if you follow through, you should be able to get that answer. So I don't know where we are, whether we need explanation more on this. Let me get thumbs up if you think you're okay and you feel okay, I understood and I made a mistake somewhere.
This is the only ones I have with her. But she looks exact.
Okay, so we're good here. Makes sense, guys. Everything we've done plays a big role. Okay, so that question is done and well understood. Whoever sent me that question, we've done quite a few now for us to understand that. Let's look at the next one. Electrostatics again. Electrostatics again. All right. Let me read this one with you quickly, but the calculation you will do. Two identical spherical balls, P and Q, each of mass 100 grams, are suspended at the same point from a ceiling by means of identical light inextensible insulating strings. Each ball carries a charge of 250 nano. I don't like seeing all of those things. I changed them immediately. What is 250 nano?
250
Times 10 to the power negative what? 9 columns. The balls come to rest in a position. Now in the diagram, the angle between each string and the vertical are the same. Give the reason. What do you think? What do you think would be the reason? Why is it 2020? All right.
Oh, because equal mass, equal charge.
They are equal charge, so they exert equal force on each other. So the charges are equal, hence the forces are also what? Equal. One is not pushing more than the other. All right? Good. So they have equal charges and they exert the same force on each other. Beautiful. State Coulomb's law in words. We're done. Okay, guys. Let's look at the calculation now. There we go. There we go. Do you want to try this? Do you want to try this? Let me help you. The free body diagram is drawn. I'm not going to do the whole thing. Calculate the magnitude of T. Okay, guys. This is what we have. Let's redraw that diagram and compare side by side. We have that and we have that. And we have the angle in between them as 20 degrees. Okay, now let's see. Let me explain this free body diagram to you in case the examiner asks you to draw and you don't know how they got this free body diagram. Which one is P? Let's see which one is P. Okay, P is the one on the left. All right, makes sense. So we have P. And we have what? Q. Now check. If I were to draw my free body, they gave us the mass. So what happened? The weight is coming down, right? Now, the force there, it's a rope. That's why we have what? That tension. Now, what is this Fe? It is electrostatic what? Force. I want to show you something here quickly. What is the charge on both of them? They are both what? Positive. So they are repelling each other. This is why the electrostatic force is in that direction. That's where the free body diagram came from. All right, so we are going back to Newton's laws. Calculate the magnitude of the tension. Let me help you here with something here quickly, guys. What is this? Yes, talk to me. Is there a hand up there? What is this angle? Let's try to do a bit of maths. Check that. If I were to draw that there, you can see that this and this are what? Parallel to each other. So what do you notice? Alternate what? Angles. This angle is 20 degrees. Please, it is very, very important that you get that angle correct. Now, can we resolve? We never work with inclined forces, right? We always work with vertical. Explain the tension direction not in left. Okay, the left one Well, okay, if I were to draw that of Q, let's draw that of Q. What will it be? What will it be for Q? I'm going to have what? The weight. Now you would notice that it is going pointing to the left hand side. So for Q, I would have that. And the electrostatic force would be that. I don't know if that makes sense. All right. So the Q would be going left while the P would be going where? Right. Just as the way the diagram is. All right. Awesome. Guys, what do we do here? Before we do Fnet, we need to resolve this. We need to resolve what? This. If you check, your force is pointing in that direction. So what do we need? We need F vertical and F what? Horizontal. In which direction? Your main force must be in the middle of both of them. All right? So Fy and what? F what? X. Already I'm getting the tension for you here. What do you notice? Now I have a 90 degrees here, and this is my what? Fx. The one that is opposite, what do we normally use? Sine. So Fx is T sine theta. While Fy is what? T. If you are not sure, my dear learners, just use your normal trig ratio. Opposite over hypotenuse. What are we looking for? Tension. I am therefore going to say Fy or Ty is equal to W. Let me know if this makes sense. I don't know if it makes sense. The force pointing up must be equal to the force pointing down because the system is at equilibrium or rest. What is Ty? T cos theta equals to what? I think we can get T now. What is the mass?
500.
Are you sure? What were we given?
Yes. 100.
100 grams. And in physics, we don't calculate in grams. It has to be what? Kilograms. So what would it be?
I don't know.
0,1. You divide by 1,000.
Oh.
What is your G? 9,8 over cos 20. Please get me an answer there. So we are using vertical forces in this case. Vertical forces.
1.04.
And we are done there. So this is Newton's laws. I want to explain something to you now, and you are going to quickly do that for me in 5 minutes. But are you okay with 7.3.1? Analysis of a free body diagram. Let me know if we got that and we are okay. Amara, are you okay? Bartley? Now, how do we get the second question? Can I look at my horizontal forces? Please check. You're going to do this for me. I'm just going to tell you something to do. What is this? Electrostatic what? Force. And what is this? Tx. Because the system is at equilibrium again, what can we say? Tx is equal to what? Electrostatic force. And what's our Tx? T sine theta equals to what? K Q1 Q2 over R squared. Guys, I think you can calculate the distance between them. Because now I know my tension. I know my tension, I know my angle, I know my K, I know my Q1, I know my Q2. All I'm looking for is R squared. You have 4 minutes. I have already done the hard work by interpreting for you. Amatle has 0.04. Your Antle has 0.014. Okay, can we get some other answers? Time up, but can we get answers? Please recheck your calculation, everybody. Check the squared where you are supposed to square. And I need more answers. Please, I only have one answer. Gracia, come. Jeda, Emmanuel, Amara, come. Arifa, Gugu, Sbartley, Martley. Amatle gave me 0.04. The rest of you, nothing. I'm waiting.
So, is it going to be sine 20 as well?
Sorry?
Sine 20.
Yeah, T sine 20.
Okay. Yeah, then it's still the same thing.
I'm waiting, people. I'm waiting. So what's our T? 1.04, right? Okay, so it is 9 times 10 to the power 9.
1.04?
That's our T, Mos.
Oh, I didn't make T 1.04.
What did you put for T?
That's why I moved 0.1.
Where is the 0.1 coming from?
Calculated mass.
All right, 9 times 10 to the power 9. What's our Q1? 250, right? I think. 250 times 10 to the power negative 9 times 250 again times 10. I'm using a calculator off screen. And I have 1.04 sine 20. Then I look for the square root of that.
There you go.
0.04.
Yeah. You see, I wasn't doing the right thing.
Okay, I don't know if you guys are still here and you can hear me because I'm not getting any answers. Somebody please give me a thumbs up or something if you are still here. Let me see if there's network or something problem. Gugu, can you please give me a thumbs up or something? I want to see if you guys are still there or I'm just alone. Alright, Gugu, can you please give me your answer? Now you can only raise your thumb. Give me answer now. Sbartley, give me answer. Amara, please just do the simple math there and give me an answer. Zero comma 04. So it's correct now.
Yes.
All right, so if you just do your substitution, guys, everything is okay. That question has been answered. T sine theta equals to K, Q1, Q2. And if I just interchange, you should be able to know that math also by now. That's T sine theta, which is 9 times 10 to the power 9 times 250 times 10 to the power negative 9. They are the same. So it's squared over what? 1.04 sine 20, and you find the square root 0.04 meters. There's a question I want us to do. It's a question on graphs. I want us to do a question on graphs. All right, so that question is done. Ooh, beautiful here. Beautiful here. We are now on work, energy, and power. Can I ask you to please do the first 3 questions? The first 3 questions. Quickly, let's revise the first 3 questions. I would help you with 5.4, but I need the first 3 questions. And you have 6, 7, so 6 minutes. should do. So with this, you can see we are touching every aspect of physics. But we haven't done Doppler. I need to do Doppler, graph, and simultaneous. All right, quickly, let's get those answers. Yep.
The coefficient has no units because they cancel.
It's a ratio of forces. Okay, so I've answered that one for you. It's a ratio of forces. Work energy theorem, please. Don't say you know it. Please write it. And draw. Why am I giving you 6 minutes? Never. There's no single calculation here. 3 minutes, please. There is no single calculation on that. We can't be playing like that. No. 2:30. 2 minutes, 30 seconds. What are you checking for your book? What energy theorem? Do you know the formula? Just change the formula into words. What is the formula? You are using the wrong one. W net equals to what?
W net time divide something divided by
Child. You're lying now. You are now lying.
Formulas, please.
W net equals to change in kinetic energy.
Change
Oh
in
yeah.
kinetic
Is
that work function? No.
W net is equal to the change in kinetic what? Energy. And that's what you write down in words. The net work done on an object is equal to its change in kinetic what? Energy. Please draw me a free body diagram. You have 30 seconds.
So is it after or before?
Read the question. I'm not going to read for you the exam.
Why it is being due? Is it still
Now leave me alone.
after?
You have 1 minute. 1 minute. Please get me answers. 50 seconds. Get me answers quickly. I can't help you in the exam. Read the question. So you want me to interpret? All right, a constant force F applied at an angle of 20 degrees above the horizontal pulls a 200 kilogram block over a distance of 3 meters on a rough horizontal surface. So it's pulling. Draw a free body diagram indicating all the forces. What force do you have? Quickly, everybody. Huh? Don't just tell me frictional. In which direction? Left is. Right is like this.
So it's going that way.
Okay, wait. Let's start. Which force are you talking about? Friction. Where's friction going? Where is the object moving? Object is moving to the left.
Yes. Also, friction is going to the right.
Please. Friction is going to the right. Friction opposes the direction of motion, not applied force. Friction. Okay. What else?
Force due to gravity.
Which is going downwards. What else?
Force applied.
Force applied. You draw it the way they have drawn it.
Yes.
And then what? Normal force, because the object is on the surface. And that's your 4 marks there. Without stressing, please make sure you get this free body diagram correct. Please and please and please. There is no excuse. Friction is opposite the direction of motion. Okay, anyway, let's answer. Now look at this. Show that the work done by friction. I'm going to take time. I'm going to do 5.4. You are going to do 5.5. Please. Show that the work done by kinetic friction can be written as that. Don't worry about that. Let's go calculate work done by what? Kinetic friction. My dear learners, once I have things like that, please, the key thing here, these questions are not difficult at all if we follow the same principle of physics. What is this? Friction. What is that?
No.
Fg. What is this? Force applied. And what is that? Normal. Now, let's look at our angle. Where's the angle? 20 degrees. Okay, so please check what I'm going to do. I have drawn that for the examiner. This is now my working diagram. I'm going to put my 20 degrees there now. All right. The force applied is an inclined. What do we need to do? We need to resolve it. Vertical and horizontal. When you resolve, that force must be in the middle. So what would that be? Fy and what? Fx. Do you see the original force? Where is it? In the middle of both of them. So what do I have? Fx, and what do I have? Fy. That's the first thing I do. The second thing is I write down the values or the expression. Look at my triangle. Please, I'm going to slow down here a little bit. That is my 20 degrees. This is Fy, and this is what? And that is F. If you are not sure, just use sine 20 and cos 20. What is sine 20? Opposite over what? Hypotenuse. So what is Fy? F sine 20 degrees. What about cos 20? So we have this fixed. Adjacent over that. What is Fx? F cos 20 degrees. Make sense? Good. Now the examiner says we should find work done by what? Friction. Please, very, very important. This question is more than 4 marks. So I'm going to take it slow. What is my new diagram looking like? If you understand this question, I think we should be good. We have that, because I've seen the amount of work that needs to be done, which the examiner wasn't taking into consideration by saying 4 marks. This is way more. then 4 marks. Check this. What do I have? Fg, Fx, Fy, N, Fk. Right? Good. Now, what do we then do here? We are looking for work done by friction. Please, this is work. I know that theta here will always be what? 180. Theta here would be what? 0. Please don't forget, the theta of friction is always, I'm underlining the word always 180 degrees. We're about to finish now so that you guys can still prepare for this. I'll write it tomorrow. Okay. But I think after this we'll be able to touch on some Doppler. Yeah. And then I think we've covered the whole of paper 1. Yeah, that's beautiful. Beautiful. Huh? Yeah. Okay, maybe on Wednesday we can just do 20 multiple choice or 40. Yeah, we can do 40 multiple choice. What do you want me to teach you until you're right? No, we're done. All right, guys. But anyway, what is the work done by friction? You have to be able to work on your own as well now. We've given you all the information that you need. Cos what? Theta. Check. I want to now lay out my work. Do I know friction?
Yes, we can find it.
We can find it. Why? How can we find it?
We have mu k and we have F.
Beautiful. So we know that coefficient of friction is mu k what? N. Please, guys, always look at your free body before you determine what N is. There are 2 forces pointing up and 1 pointing down. What does that tell you? Fy plus N is equal to what? Fg. What is N therefore? Fg minus Fy. What is Fg? Mg minus, what is Fy? F sine 20 degrees. I hope my analysis makes sense to you. All right. So now can we get our friction? What is our coefficient? 0.2. What is our N? Let's bring that in. Or let's do it here. Into bracket mg minus f sine 20 degrees. Let's walk through. What is the mass? 200. Huh? Okay, let's check the mass. 200. And distance is what? 3 meters, right? Okay, so what do we have? Let's replace together. Let's walk together. 200 times 9,8 minus f sine what? 20. All right. Let's multiply this and all of this. What is 200 times 9,8 times 0,2? Times 0,2. That's what they're doing. 1176. What's your answer?
Do you want F? You want me to calculate?
We cannot put F.
Why don't you know F?
You don't know F.
So then I just divide by...
No, Charles, can you just give me 0,2 times 200 times 9,8?
Oh, then that's 392.
Yeah, that's all I need.
Okay.
Minus. We don't know F, and they're not like terms. All right. So what is this? 0,2 F sine what? 20 degrees. That is my friction. Mathematics now. But I'm not looking for friction. I'm looking for work done by friction. So what is work done by friction? It is frictional force delta x cos theta. Now, do I know my friction? 392 minus 0,2 F sine 20. My displacement is 3. and I have cos what? 180. Cos 180 is negative 1. Negative 1 times 3 is what? Negative 3. I'm going to try to simplify it for you. So it's negative 3, 392 minus 0, 2f sine 20. What do we do? Expand the bracket. 392 times 3 would give us what? Negative 6, 7, 11. What is negative times negative? Positive. Now, let me get a calculator. I am multiplying everything there by what? By 3. 3 times 0, 2 sine 20. Don't worry about the cos. F. 0,205 F. And everything is in check. Look at the answer they ask us to prove. We are done with that answer. Look at it. Negative 1176 plus 0,205 F. Please let me know if the analysis makes sense to you. Please do let me know if the analysis makes sense to you. If you are okay with the analysis. All right, thank you, Jada, because we thought you were all watching Netflix. All right, so guys, that's how to work it out. Please, you see it's more than 4 marks. It's really more than 4 marks. But I think the examiner was checking if we put too many marks and learners don't get it right, they'll be losing too many marks. All right, but this is the outlay. Answer is in the free body what? Diagram. Okay, if there's any question, you can always bring me back. But if we are okay with this, or if you can rewatch to understand. Guys, we are done with paper 1. Well done. Calculate the magnitude of the force. So we are looking for F right now, right? That has to be applied so that the net work done by all the forces on the block is what? 0. The net work done should be equal to what? 0. I still need my free body what? Diagram. I want the net work done to be equal to 0. So let's use our free body diagram. And what are we going to say? W net. Here's the deal. How many forces are we looking at? Look at your free body diagram. How many forces are doing work? 5. But how many are doing work?
1, 2.
Only 2 are doing work. No. It is. These are the only 2 that are working. The work done by FG will be equal to 0. It doesn't cancel out. Why? Because it is perpendicular to the displacement, and cos 90 is equal to what? 0. These 2 as well, W equals to 0. Again, perpendicular. Are we okay? So what forces are now working? Please, I want you to do the calculation for me. We are now saying work done by what? Fx plus work done by what? Friction must be equal to what? How do we calculate work done? It is the force delta x. Fx delta x cos theta. Do we know work done by friction? I think we do. We are looking for f, right? But what is fx? I think we have an answer for fx. We do. It means you are losing connection and thoughts with this.
Oh, yes.
All right. So f cos. Guys, with this, take your time. Substitute carefully. What is my delta x? 3. What is the theta here? 0. Do you see? All my answers are already on the free body what? Diagram. Plus. Now, what is my work done by friction? Plus. And that should be equal to what? 0. Please calculate and get me f. Let's see your maths. Calculate and please ask me any question that you feel you might be having. Let's get f. Let's do the maths now. The major work has been done. 3 minutes. Please, let's work out f. Let's do the maths as quickly as possible. Beat the time. Do we have an answer for F? Share answers. Amatli is giving me 388,88. Is that what you have as well? This one is 3 cancel. I can't see.
Yeah, it's 388, come on. Yeah.
Anybody other person confirming? All right. So it's just the maths there. Please let me know if we are not sure. You said 388. Comma 88. Emmanuel, Jada, is that answer? You agree with that answer, Spartley?
How do I calculate it?
Huh?
How do I calculate it?
Calculate what?
F.
You didn't get it.
I did get it, but just to confirm that I got the right thing.
No, as long as you got it, there's no other way. Just expand the thing, that's all.
Yeah, that's 3.
So that is 3F cos 20 minus 1176 plus 0205F. All right, let's move the 1176 over to the other side, and I see my F is common. You see, I'm going to even use my calculator once. Then what is my F? It is 1176 over 3 cos 20 plus that 388,88. All right, there we go. So please don't get the question scare you. Just interpret normally. Big problems need simple steps. The questions may look but relax. What are you checking? Are you okay?
Yeah.
All right. I hope everybody's okay with the step. Okay, let's see. What's next? Oh, finally. Doppler. I need Doppler with a graph. I need Doppler. Okay, then we have this. I think who sent me this? I don't remember. Electrostatics again. But let's see quickly. Let's look at that Doppler. Then we can say we rest. But I'm going to have to do Doppler. Okay, we need to do more vertical. Doppler. Yeah, I think we can do one or two more. 2 verticals. Momentum. Maybe 1 or 2 as well. One with a simultaneous. And we do Doppler. We should be all good. All right, thank you. Oh, Emmanuel, you sorted now. All right, reflection of sound waves enable bats to hunt for moth. This we shouldn't waste time. The sound wave produced by a bat has a frequency of 2. I already see your question as I'm talking. I see your question as I'm talking. You want to know? Huh? I see your question as I'm talking. Okay, I'll talk about it. But let's answer this. The bat has a frequency of 222 kilohertz and a wavelength of that. Calculate the speed. Please, here the problem is learners mix a whole lot of things. Speed of sound is V. What do we have? We have wavelength. We have frequency. So what do we say? V equals to what? F lambda. What is our frequency? 222,000. Kilo is 1,000. Yeah, so you have to convert to hertz. What's our wavelength? 1 comma. A kilo is 1,000. I just converted.
Oh, okay.
Kilo is 1,000. Please give me an answer. Comma. And you get your 3 marks there. Done. Now, a stationary bat sends, please, very important, read. A stationary bat sends out sound signals and receives. This is very confusing. Please, you can see 6 marks here. The bat sends out. Okay, let's look at this. The bat is stationary, right? So the bat becomes what? The source. It sends out waves, all right, and receives the same signal. So the bat is serving as what? The source and what? The listener. All right, from a moving okay, wait, it sends out at 222 and receive the same signal reflected moving at what? 230. What do you notice? What do you notice about the values? It receives a higher. What does that tell you about the moth? Is the moth moving towards or away? The moth is moving towards, because every time we have higher, it has to get, no, it doesn't get really louder. Yes, so it must be towards. Frequency increases, all right, as the object moves what? Towards. Whether the source or the listener, we don't care. As long as it's towards, frequency must what? Increase. Calculate the velocity of the moth, assuming the velocity is constant. Okay, let's try to create something here. So what are we looking at? We're looking at a bath and what? The moth. The moth is now my what? Source. Does that make sense? Because the sound wave is reflected. The bath becomes what? The listener. Velocity is what? 0. What is FL? 230 0.3 kilohertz, right? Remember the 3 means multiplied by what? 1,000. That's K. What is the frequency of the thing in here?
Unknown.
It's known. It's known. That's 222. All right. So what's our formula? We are dealing with what? Towards, right? Whenever I know that it's towards, it's positive over what? Negative. Once I see towards, now what's our formula? FL equals to V plus or minus VL over V plus or minus VS. Which one is stationary? VL. I like to always just remove the one that is stationary. And I have what? FS. Can we do the substitution now and you do the math for me? What is my FL? 230. If you multiply by 1,000, what do you get? Equals to, do we have the speed of sound? 333. Please use whatever they give you over 333 minus VS. Everything multiplied by what? 222,000. Please do the maths. Let's check your maths. Let's give you 2.5 minutes for the maths. Or for writing, I know you are still writing, so 3 minutes. And calculating as well. All right, you guys are giving me 12. Is that correct? You have 12 as well. Okay, let's do the math quickly in case somebody doesn't know what to do. What do? We start by dividing. All right, so it's going to be 230 300 over what? 222 000, and that is 333 over what? 333 minus VS. You can.
2303 over 2220.
Sorry?
2303
2303.
over 2220.
All right, the 2 zeros cancel out, right? Okay, so we can basically cross multiply. All right, let's do this. I'm going to cross multiply, but check what I'm going to do. Will be 333 multiplied by 2220 over. I'm crazy with my math, Shem. I know you didn't do it, don't worry. For me, I just switch these two and then cross multiply that. Don't worry, to give it the same. Then what do you say? Vs equals to 3 minus this entire thing. I like to do a lot of mental maths. I don't like calculators. Now I use calculator once. Alright, but whichever way works for you, make sure you do it. Alright, I hope everything is okay. Just do what, and that question is over. Alright, let's quickly summarize blue shift and red shift. Blue shift and red shift. Quickly. What is it that I should know about red shift? Fine. Number one, definition. The spectral lines shift towards the red end. And what do we have about the red end? Longer what? Wavelength. Which is something as what? Low frequency. Of the spectrum. Indicating that the object is moving away. Indicating that the object is moving away. Either the source or the listener. And a quick way that I look at this is I just ask myself, what's the color of danger?
Red.
What do you do when you see danger? Run where? Good. So red shift is away. Make sense? Danger is red and you run what? Away. So if the examiner asks you to draw, look, a simple example of a red shift, I'll do this. And this is what they would ask you on Friday. This graph will be there. This.
Okay, you must stop saying that. You said that about 10 chords.
I said you should learn, but you should learn tan chord twice. Check. Do you notice that the question today, you use tan chord more?
Yes.
Tan.
Yeah, like half of those pieces.
Half of those are tan chord, tan chord, tan chord. Don't belittle my instructions. Most of the reasons, tan chord, tan chord, tan chord. So there was something I was hearing in my ears about tan chord. Okay. What is this here? You can see the object is moving what? Away. Hence we have what? Long what? Wavelength. Low frequency. And this is what? Red shift. But this is how they are going to test you in the exam. A and B. Oh no, let's say this is how they'll put it in the exam. What do I want to do? Okay, it's fine. Let me use A and B. They are going to draw spectral lines.
And you know what I hate? Those lines are always blurred. You can't see anything.
No, you should be able to see.
Like I said, it's blurred at the end of the definition. Today they gave us a nice drawing of a house.
Oh, yeah, it was nice. All right, I'm going to draw two spectrums here. All right, and then I'll draw another one here. Let's use a green one. Or let me shift it. Somebody's saying, okay, what is this guy drawing now? I will show you now. These lines are drawn strategically. This one should be more. Now, if I were to number these lines, 1, 2, 3, 4, it's the same lines that I have here. And it's the same lines that I have here. Alright, this is the original one. What can you tell me about the yellow lines and the green lines? They have moved to the right. That's a red shift. That's how they're going to ask you what type of shift. Is the object moving away? So they're going to tell you this is measured from distance. This is when the object is from a far distance. So we are seeing that both of them are what? Red shifted. How do I know? The spectral lines have shifted towards the red end. Can you see where our original 5 and the new 5s? The new 5s are towards the what? Red end. That's a red shift now. That's what we mean. The spectral lines have shifted towards the red end. But here's the question they're going to ask you. Let's call this star A or star X and star Y. Which one is moving faster? Which one is moving faster? X is moving faster than Y. Why? It is more red shifted than Y. So I'm going to put my answers here for you.
Wait, how? Because one of green is further away than one of...
No, I think my diagram is wrong. No, this one is supposed to be here. They are more red shifted, so it's moving at a faster pace. X and Y are both red shifted, are moving away. Why are they moving away? The spectral lines have moved towards the red end, which is just an explanation. I'm rewriting that. Please, I didn't say the red color. Don't use the word color there. But we are saying X is moving faster than what? Than Y. Why? It is X is more red what? Shifted. And the same is the blue. For blue shift, what are we going to do? What are we going to do?
Everything is going to move that side.
Everything is moving the opposites. All right? And blue now becomes what? Towards. Blue becomes towards. Let me know if that makes sense, everybody. We have one more question, then next session I'm going to look for what else I was going to look for? A graph on Doppler. I need to do a graph. Are we okay? Everybody good? Mm-hmm. All right, so if it's a blue shift, then we know it is what? Towards. Anything you see red there, just change it. The spectral line shift towards the what? Blue end. What would that be? Short wavelength and what? High frequency of the spectrum. End of story. Also, please listen to my song. Let's give that song some views now.
Where's your song? On YouTube?
Yes.
What's it called?
It's a house song. Choo choo choo.
Say what's the song called?
Choo choo choo. Like the chew of a train. TSHU. Let me show you. Yeah, 3 shoes. No. H, this child. Okay, so you just go there. If you just type 222 alone, it might give you quite a number of songs. So to make it easy, type Crazy Physics 222. It might give you a whole number. What happened now? All right. Okay, once I say Crazy Physics 2, it must be able to bring it out. There we go. Doppler effect. 1.8 views. Too low. Let's pump it up a little bit.
Since I watch it every day.
You will know the whole of Doppler. Yeah, it's a Nama piano song. 7 minutes. You know the whole of Doppler.
You know I don't listen to my piano.
This will be the first one you will listen to. It's actually 5 minutes. 5 minutes and 20. All the lyrics. You'll even learn how to dance. I know you don't know how to dance. You have 2 left legs. All right, people. Let's look at the last question. So that's your red shift and blue shift. If you find any question that is not so clear, we can also then look at it. Okay, let's look at this one. Let's look at this one. Charges A and B and another charge D, okay, I know the diagram may look a bit scary, are now arranged a rectangle. Okay, this question, but wait, this question is a continuation from a question that we don't have. All right, I hope we don't need the charge on A and D. Charges sphere A and B and another charge D are now, can you see the word now? Means it's continuation from somewhere. Arranged along a rectangular system of axes, as shown in the diagram below. The net electrostatic force experienced by A is 4,69 in the direction as shown in the diagram. All right. Is the charge on D positive or negative? Who gave me this question? I don't remember. I need the beginning of the question, because I cannot really answer this if I don't know. I'm not sure. So we need to find the origin of this question for us to be able to answer it effectively. I'll have to check my phone now to check who sent that question. All right, let's find the source and the origin, because we need 7.1, 7.2 to be able to answer this. So I'm going to skip this for now. I've actually come to the end of the questions that I've received so far. However, let me think of one quickly, everybody. 20, where is it? Let's look at 2022. Just want to check something quickly. Mpumalanga, paper 1. All right, this looks like a simultaneous. Let's get this out of the way. I think it's simultaneous. Let's get this out of the way. I wanted something else, but not bad. Not bad. I know Pumalanga once asked something like a graph. Let's see if we can just spend 10 minutes on this. And we are all tired from paper 2 maths. I don't know if this is visible enough. This is some Pumalanga. Is it visible enough for those of us at home? Are you at home? Those of us at home, is this visible enough? Let me know. All right, thank you. The siren of a stationary, okay, we want to work quickly, guys. We want to work. You are going to do most of the work for me. The siren of a stationary ambulance emits sound waves at a constant frequency. The diagram below shows a learner next to a stationary detector that registers the frequency of that. The detector registers the frequency as the ambulance moves at constant speed. Please put this note down and remind me. Graph, I know I did it, but remind me. Graphs when the speed is changing. Graphs when the speed is changing. All right. The graph below shows the changes in detected frequency versus time as the ambulance approaches and moves away. So we have two frequencies there. Approaches and moves away. Which one is going to be the higher one? Approaches. So don't let's forget that. Once it's approach, it's higher. So this is what? Towards, and this will be what? State Doppler effect. Please let's learn that definition. Explain in terms of wavelength and the number of waves that reaches the detector why the observed frequency is higher when the ambulance moves towards. Let me help you with that explanation. 6.2. As the ambulance moves towards, or approaches, two things will happen. A, number one, more wave fronts reach the listener per second. Number two, explain in terms of wavelength. You see, we're already done with number of waves, right? That's number of waves. More wavefronts reach the listener per second. What about wavelength? The wavelength does what? Decreases, right? As the waves reach the listener in closer succession. We are done. Even if you don't put the word closer succession. More waves. So the waves are compressed. That's what we're saying. The waves are compressed. This is what I'm saying. So the waves coming are like this. But when they get here, they are not like that. You can draw that diagram to help you also see. These are the ones coming. But when they are hitting because they are now close to each other, this is wavelength. Can you see the wavelength here? It's now what? Shorter. That's why the frequency becomes higher. Calculate the speed of the ambulance. Do you want to do this for me? Calculate the speed of the ambulance. I'll give you 5 minutes. You have all the information you need. Let's see. Can you walk through? Then we finish in 5. All right, tell me we did it. Tell me we did it. So when you see something like this, we have towards and away. Please don't say that they've given you the frequency of the thing. They didn't give us. So we have to work towards and away separately. Let's quickly get that done. Our time is up already, but let's get this done and finito. Then we can all just rest a little bit. But those of you writing tomorrow, rest and fire again. But physics, I think, guys, we are ready. Was it 9:50 here?
Yeah.
And then here?
7:50.
Okay, good. Now, what is my towards formula? Remember, towards plus over minus, right? So FL equals to V plus or minus VL. Please always write the formula first. Which one is stationary? The listener. So VL is equal to what? 0. Look at what we are going to do very fast. It takes 3 minutes or so. Substitute for towards. V over V minus Vs Fs. For towards, listener is 950. V, oh no, what is V? 340. What are we given? Huh?
No. Yes, 330.
330.
Yes.
You sure?
Yes.
Over 330. Now, we do not know the frequency of the listener. Guys, look at what I'm going to do. Here's what I want you to see. This is over 1. 950 multiplied by 33, that is equal to 330 Fs. Equation 1. Then we come for the away. This one is towards. 2 minutes. Let's finish. FL, it's now minus on top and plus at the bottom. V plus Vs. My board needs to be restarted. Fs. Okay, what's our FL? 750, 330 over 330 plus Vs. Please, once you see this, multiply 750 and that is 330 what? Fs. Anneli, I want you to see I want you to see something. Check here. Look at what I'm going to do. I don't know what you did after that. Look at my equation 1 and my equation what? 2. I don't need to find them. Can you see both of them are equal to 330 Fs? I'm just going to equate quickly. 950 330 minus Vs equals to 750 330 plus, and I'm done. I'll be able to get what I need now by doing that expansion. It's simpler that way. All right. Do you want to help me? 950 times 330. Help me here quickly. Copy from me. 3135 minus 950 Vs. Next one. 750 times 330. 330. 247 plus 750 what? Vs. We are done already with the math, right? If you bring that one over, you have 313 500 minus 247 500 will be what? 750 Vs plus 950 Vs. I'm sure everyone can do the maths there now. We just add and we divide. Why am I getting that? So what do we say? 3135 what? 00 minus 247 500 divided by 750 plus 950. What's your answer? 38,82. So that's how we do the simultaneous equation, guys. That's how we do you do the equation of away and towards, and then you solve. All right, finally for the day, I said 2 minutes, but I've taken 3 minutes. Calculate the distance between the ambulance and the detector, 12.5 seconds after the detector started registering. All right, what are we looking for? The distance. What do we do? Which one is moving? The listener is moving. No, the source is moving, right? Good. So we can simply use our equations of motion. We have velocity. Initial velocity is 38. I want to show you something. Even the final is the same. Do you know why? Velocity is what? Constant. Time, 12.5 seconds. We are looking for what? Delta x. Vi delta t plus half a delta t squared. What is our Vi? 38.82. What's our time? The whole of this is 0. Do you know why? At constant velocity, acceleration is 0. Put that in a calculator, and I think we should be done there. Just want to see something quickly on the 12.5. Just want to see if we interpreted well. Calculate the distance between the ambulance and the detector after the detector started registering the frequency. Oh yeah, so it's correct. So moving away, 12.5 seconds. So we calculate the distance. What's your answer?
485.2.
All right, and that is it, guys, for today. I hope it makes sense and we learned a lot. Thank you for all the questions that came through. We need to find the source of that first question, and I think I have some questions that I put together. Then I'll look for Doppler again, and then we should be ready for physics. We'll also tackle some multiple choice next week. Are we all good, everybody? I'm okay, but I'm tired now. All right, let's go rest and prepare. If you don't have a paper tomorrow, good luck. You can sleep a bit. If you have a paper tomorrow, you also sleep a bit, but wake up knowing that you have to catch up. Have a lovely, lovely evening, everybody, and see you when we do the last paper 1 session, which would be session number 8. Again, mixed questions. If you have questions that you come across between today and tomorrow, please send them through and let's walk through together. Yes, please also send Chem. I don't want us to just wait, for the weekend. Goodbye.